Guys, this video will cover ACT 44 science section. Okay, science section, we don't read passage, we'll just go straight to the question, and then if you can find all the evidence, that's it. Okay, number one, according to table one, what percent of, so table one, if you read this one, what percent of pearly mussel species native North America, not be placed in the category based on their risk of extinction. So this is risk of extinction part, insufficient data, so 4%. This is B. Number two, based on figure one, how many pearly mussel most likely present in the Hudson River estuary? Zebra mussel became abundant there. So you go figure one. It says native pearly mussel, millions, and then abundant means like, maybe like this, So it's like between 11 and 12 million. This. Okay, G. Based on table one, what percent of pearly mussel species native in North America were scientists able to place in risk, not classified extinction or stable? One. So we cut out the 7 and 24, which is 31%, and also we take out this 4% as well. So 35%, which is 65. Number four, the damaged pearly species, plus figure one, if all the zebra mussel in the Hudson River area removed in 2020, population area for 2005 most likely would have. So 2002 right now is this much, right? So it's going to go up because we don't know how far it goes up, but we know at least it's going to go up. So it's more than like whatever 200 million. Greater, okay, J. Which of the mussels, zebra mussel or pearly mussels, if either would, when encountered in the Hudson River estuary, considered invasive species? Zebra mussel. The zebra mussel is the one that kills. It looks like, it kills the other one. That's why number four, it's like opposite way to go. If it is like more zebra mussels, we have less pearly mussels. Okay, number six, based on figure two, we'll go figure two, 1.1, which is here. Diodous triangles, so it's going to go up like this, probably here, and greater than 130. Okay. Energy increase I, so we have to find the energy and I. Energy I increase, energy increase, so directly proportional, which is A. Number 8, for device following Ohm's law, the ratio of voltage device to the current flowing device, the device's to flowing current is constant based on the figure 2. Which of three devices following the Ohm through this? So figure 2. So energy, it says the voltage across device to current flow, so which is the voltage V over I has to be constant, same number that we have to have, right? So if you think about the figure 2, let's say I'll say the constant speed, which is like, the the straight line, that shows constant. That's why only resistor and light bulbs, not diode. So H. And then based on 2 and 3, R for the diode equals 60. And I closest to which one? So R is from here, so 60. You can see B as a 0.7. So you see B as 0.7. I is around 10 or 15 or whatever you see. So 12 right here, A. Based on figure 3, conducted electricity based on when E for the diode equated, which are the following. So something that is diode and what is it? Question. Conduct electricity when diode equated, which are the following. Electricity we see from the, I guess, light bulbs. So diode and light bulbs are kind of like, you know, like meeting right here. So it's like 85 range. It's close enough as a such a. Let's move on. So 11, suppose the additional trial, study 1, H equals 0.5 here. And then obviously Y is around 6.5. Suppose while the testing the particular ball during the study 2, the students obtain the value C greater than 1. Greater than 1, there's no greater than 1 here. Following statement. Collision, false collision, concrete surface, formed surface. So C means here, let's see. Coefficient of restitution is a C. So the collision itself. So Y, so if you just like, you know, go right here. So 1 means we have to understand the C. C is Y over H. Y is the distance and H is what? Height above the surface. Okay, and Y is maximum height. Okay, so it is less than 1 because Y maximum height, and then H is the ball dropped from the height H, and maximum height. Okay, bounce straight up, bounce up. So you drop it, bounce and up. So it doesn't come all the way up here. That's why it cannot be 1. But then greater than 1 means you cannot just drop it. You have to like throw it. Otherwise, it cannot go all the way up there. So which is H, yeah. Using kind of common sense here too. 13, suppose the additional trial, study 2 student dropped ball concrete surface, stuck surface without bouncing. Without bouncing means 0. Yeah. It doesn't come up at all. So it's like stuck there. Maybe like, you know, gooey, the rubber thing, maybe. Slime, maybe, I don't know. So determine the surface tested study 1, more likely bare concrete, form covered concrete. 1 of the compare C study 1 and each C study 2 for. So we see the slope of this one, like 1, H is 1, Y is 0.8. So Y over 1, so 0.8. So we have to find something with 0.8 concrete, 0.8 is this is a foam covered. Okay, so it's like it's between racquetball and golf ball. Hold on a second. Bare concrete or formed concrete. One of compares C form. So both of them has to be, right? So it's like you have to racquetball has to be. Because at least it has to like, show the difference enough, I guess. 0.8 coming up. And then racquetball, it shows like a little bit more than golf ball, I guess. Because they're testing about this. 15, supposed to study 2. The steel ball was dropped into the concrete and then height 2.0, most likely, approximately. The steel ball have bounced into collision where concrete and covered. Steel ball here, it says 0.65 and 0.24. So right now is dropping from what? Oh, we don't know height. So, but then height is 2.0. So H is 2.0. So study 1, H is 2.0. Oh, no, hold on. Steel ball. So it has to be. Right now, the difference is this much, but then that's like based on 1 meter. So the difference right now is around 23.23. But then if you double it, that becomes 0.446. So roughly, I'll say like C. 16, following statements best explains student conducted location referred to as the most likely want to decrease force exerted gravity, decrease force exerted arrows, resistance. Yeah, G. Because resistance is always there, like when you drop it, right? So, right. Okay, move on to next passage, 17. What treatment result in greatest average dry shoot biomass per plant, RP? Treatment, let's see, it says, what to find something about dry shoot. Right here, you can see this one and this one. That's like the dry shoot is the first one only. We have to look at this figure 1. And then it says, which treatment? Lowest one. Lowest one is, besides RP, is all like lowest one is treatment for. But which treatment result in greatest average? Oh, RP plant. Greatest is treatment for, yeah. 18, it says the roots were washed after harvest, most likely insured. If you think about just common sense, I don't even know what's going on here, but then when you think about they wash it off, it means it looks like they take away everything in the root, so which means they make the control group. So no other effect on the roots besides whatever the treatment that they have. F, root have an opportunity to sprout intracellular. Yeah, H. Take out everything, whatever on the root. 19, water level maintained 2 centimeters above surface, which floodplain plants, the key species plants, S species plant, greater average dry root biomass per So let's just see. So first of all, like S, the blood sensitive is S and blood tolerance is T. So obviously, if you think about it, like, with common sense, 2 centimeter up, which means tolerance will, like, do better because that's what it is, right? So sensitive one is, it has to be dry, right? So having said that, if you think about AP is T, FA is T, and then RP is T as well. So then when you think about dry root biomass plant, which is figure 2, here, that whatever treatment that we have, 2 centimeter is treatment 3 here. So treatment 3 is the third one. So RP, third one is a little bit higher here. Okay, let's go back to this one. The T plant, where's the S plant dry? Okay. So we have to think about T plant and T plant is RP. RP is like way greater than other S plant. S plant AM is really low, right? And then FR is also really low. So just like obviously huge hike up. So T plant A. So which following equation most likely use collect the data present figure 1. So figure 1. I try to make like T and S, all the classification. Microscope balance, hydrometer, ruler balance. Yes. And then which following comparison of shoot biomass and the root biomass, the result of regard to water level. To make the the consistent results, you have to keep the whatever control group, and also oh no, this question is nothing to do with that. So the shoot biomass and the root biomass, if you think about overall idea of like which one grow like more, and also the scale itself is different. Like shoot biomass is like scale is up to 16 and root biomass is only up to 5. So shoot biomass is much higher. And then yeah, both of them produce potential biomass is much higher. So it's A. For how many different genuses, which is, species is 6, right? But then the genus is only like 1 to 3 because genus is one level higher. So that's why it is 3. Move on to next passage, straight to the question. Based on the description, experiment 1, which following diagram showed a apparatus that was used with this. Okay. Experiment 1, it says, beaker contain 20 milliliter, then fluid place 25 millimeter. Okay, so milliliter wise, let's see. And also, it says at the bottom, that can be opened to dispense precise volume of liquid. Because of that, open in the bottom, which is B. 24, which of the following statements describe difference between experiment 1 and 3? 1 and 3. 3 produce experiment 1 repeated with UAZ instead of UAX. UAZ is a different solution they're talking about. Okay, let's go here. Yeah, H, because difference like UAG and UAX, the difference of those. And then those are like, 25, hydrazolic acid, weaker acid, formic acid, but stronger acid than is acetic acid. Based on table 1, pKa hydrochloric acid is table 1. Formic acid is 3.7 and acetic is 4.8. And it says greater than formic and less than acetic, right? So C. Experiment 2, neutral when volume of this one, edit the value between. So experiment 2, it's like neutral. Looks like this one, equivalence point is a neutral. So it's like around 20. 20J. 27 student claimed that UAX is based on the table 1 and figure 1. This claim is incorrect because pKa acid is, so table 1, 2.5 right here. And then table 1, it says what? See, figure 1, table 1, claimed incorrect. pKa aerobic. 2.5. So we have to understand what's going on a little bit because I can't do it right away without understanding what's going on. So you have to read the first paragraph containing the different acids that it goes, this, and then study what experiment 1. It says bury the bottom is solution, record this solution while solve this. Recorded. Okay. And then equivalent point indicate the volume solution needed reaction. At the halfway point volume, so added as a whole, half of the volume needed to reach the equivalent point. pH solution beaker equal, here, pH solution in the beaker equal pKa acid in the solution. Okay, pKa is 2.5, half point is about 5, pH is higher. That's why it is C. Okay. And then 28, suppose experiment 3 is repeated. Concentrated is at 2.0. Well, the volume is a half point. So figure 3. So figure 3, if you see it says 0.2. 0.2 is 0.2 is 200 right here. No, hold on a second. Yeah, experiment 1 in the beginning it says 0.1 right now. So 0.2 means like double of this one, right? 0.2. You have to double it up, and then that means we have more volume added. So then instead of here, the equivalence point has to be like, like closer, I guess. So both of them less, because like it is like, you're putting more, so it actually reacts like, better and then faster, I guess. Move on to next one. This one is about passive reading. You have to read first and understand what's going on. The teacher showed 2 beakers, chemistry class. 1 beaker contains mineral oil and the other contains water. Solid iodine added each beaker. Solid iodine quickly dissolves the mineral oil and turn pink. And the solids at the bottom of this remain colorless. The student explain why. Student 1 made up every large molecules, while H2 was very small molecules. So it says solid dissolve in a solvent. Molecule must squeeze in between solvent and molecule mass, blah, blah, blah. And then 2, it says molecule polar, because it's region positive charge. And then this polar attract each other, non-polar. The polar molecule repel non-polar molecule. Okay. So 2 is correct, but one exception, non-polar molecule actually strong. You attract to the polar molecule. Okay, let's do this then. 29. Following best describe mixture of iodine and solvent. Each beaker at the end of teacher's demonstration. Iodine, mineral oil is 1, right? They're mixed together, and then H2O, no. So this is whatever you see from homogeneous and hetero, which is C. Student 1's explanation, H2O solvent, mineral oil. Yes, because the bigger, the larger space that, the mineral oil has. 31, how would student 1 most likely rank 3 substance use a demonstration? So probably like a mineral oil is the largest, and then iodine is middle, and H2O is the less. That's why iodine only like, solvable for to the mineral oil, not H2O. That's like, whatever description of this one. 32, student 2 explain the reduction, and therefore iodine dissolved mineral oil, but not in the water. Polar, not non-polar and polar. 2. So H and J is wrong. We can find H2O is polar, and then if it is polar, it doesn't attract to non-polar, right? So iodine is non-polar. That's why it doesn't attract. This is F. Suppose it was observed and the mineral oil molecules were smaller than iodine molecules. This is the 3 explanation. Smaller. No, student 3 is all about like following student 2, but except the one condition, non-polar still attract, right? So this is nothing to do with the size of it. So which is D. 34. Paraffin wax is non-polar solid, and acetic acid is polar solvent. Student 3. Student 3 with paraffin soluble acetic acid. Student 3 says non-polar substance don't dissolve in polar substance. It says that's why it is no. It's not dissolve. It doesn't attract. 35, non-polar solid 910 has molecule mass of this one. Inconsistent with, so right now the bigger one, the first substance is bigger, 330, right? And then the next one is 378. So which means this is supposed to, like, it shouldn't dissolve because solvent has to be greater size, but this is opposite, right? So, but then non-polar polar part dissolve into. So non-polar, so it doesn't. It's attract. It's dissolved. That's fine. So that's why only like in A, student one. Okay, the size matters, and then non-polar and non-polar attract each other. That's fine. So it's a dissolvable. So it's A is only. And then the very last one that we need to do here, 36, according to figure 2, which following average dune spacing and average dune height would most likely desert D dune 2. Desert D is this one right here. Right. Space. Average space is around like 1,000 something, and then height is around like 8, 9, 10, kind of like the range. Go here, okay, 1007J. Assuming that the dunes represent figure 2 as average wind speed increase, then it's going to be spread out more, I guess. Height increase, decrease, average height increase. Digit. So A and B, if you compare A and B, A is smaller area and B is larger area. So smaller area means like height will be like greater, I guess, right? Because it's like, up. And then, yeah. So that's why it's up here, high up. And then this is spread out like, more. Because of that, yeah, A, greater average in height. And then it can like increase more, spread out the wind because of wind. 38, according to figure 3, across 25-kilometer wide cross section of dune Titan, how surface elevation of Titan dune differ if from the surface elevation A. Surface elevation Titan dune is 25-kilometer. 25-kilometer, your Titan is up and down more, right, than desert A. So surface elevation is going up, down more. And how does surface elevation, if at all, from the surface elevation A, the surface elevation Titan dune is greater. And then sometimes goes less, up and down. So J, right? It's not like a one particular thing. 39, consider figure 2, greater area, height shown, area Titan dune, and how many times higher than greatest average dune height shown area of desert C dune. C is this one. Greatest average is like around 10, 11. Titan is around like, 150 range. So, yeah, E. The two quantities for dunes that are defined figure 1 and dunes space and dune height are directly analogous to which two quantities in electromagnetic waves. Okay, so Gene height and gene space. Electromagnetic. Gene spacing looks like going up and down, right? Up, down, gene space. It looks like the sine graph or cosine graph. And gene height is just going up and down. So gene height up and down is amplitude. So it has to be between G and H. Wavelength is how far it's going one to the other one. But then gene spacing is how close there are. So gene spacing is more about frequency, how often it goes up and down, so that tight or not. So it is H. No, frequency. What am I thinking? So frequency is how often going up and down. It has nothing to do with the space itself. So the wavelength itself. Okay, that's it for science section. I hope that this video helped you to understand how to do with science section. Not making mistake is the most important thing. So try to focus more and do whatever you can do. Okay, I'll come back with other videos soon. I'll see you later. Bye-bye.